My name is Daniel Reitemeyer and I'm business developer at SCANLAB. SCANLAB is the world-leading manufacturer for laser scan systems, delivering more than 40,000 scan systems per year in several manufacturing industries like automotive car body welding, micro machining, display manufacturing, also medical devices, and of course additive manufacturing. Whenever you see an industrial laser machine with fast-moving laser beams, it's probably SCANLAB inside. Our beam deflection units are the core of this machine, moving the laser spot around.
I'm Holger Schlüter, Head of Business Development at SCANLAB. Computing power has been increasing ever since, and now we are at the tipping point so that SCANLAB can revolutionize the way laser beams are programmed. We took all our experience of 33 years and put it into a new software package called Scan Motion Control.
So of course we deliver world-class SDKs, but often our customers need more. So we teamed up with the world-leading CAD provider Autodesk.
I'm Alexander Oster and I work in the Fusion 360 product development group here at Autodesk. At Autodesk we have been striving to bring design and manufacturing capabilities to a mainstream market for over a decade now. Millions of users are using Fusion 360 to design their products, to make their products, to simulate their products, and to bring them to market. With SCANLAB we went beyond the build file and started to create an end-to-end product solution and make a software stack that allows anybody who wants to make a custom additive manufacturing machine take off-the-shelf components, put them together and just modify them for their needs.
My name is Katrin Budi. I'm professor for laser-based additive manufacturing at the Technische Universität of Munich. We are dealing with completely new additive manufacturing technologies. Therefore, we started a collaboration with Autodesk because we needed a completely open software environment. Together with Autodesk, the TU Munich has developed this closed loop between CAD, CAM and the printing process. We are dealing with different beam shaping technologies and therefore we need open hardware but also open software platforms like the Autodesk Machine Control Framework.
I'm Richard Off. I'm working at the Professorship of Laser-based Additive Manufacturing at the TU Munich. I started at the chair with my master thesis and therefore have implemented a new process control system together with Autodesk and SCANLAB for our all-new Fusion chatting machine. I had only 6 weeks of time to program the software stack. Therefore, I needed comprehensive, easy to use and adjustable software for our process. Autodesk Fusion offered all that and therefore I made it in time.
My name is David Wenzler. I'm a research associate here at the IWB, building up test stands for our research. In my research, I need access into the machine. We started with using commercial machines and trying to access them. This is a bit difficult to do since we don't have access to the machine control. In the next step, we started building small test benches. Here, Autodesk Fusion helped us to control these test benches. From the lab scale of these test benches, we moved then to the industrial scale, to the real scale of the process. The cool thing is, with this upgraded machine and the high-end hardware we integrated from SCANLAB, we can control the process inline using more than one laser. Here, Autodesk Fusion was a project partner from the beginning of the project, helping us to develop the software of the system and to integrate all modules into one framework. With this open source machine, we will boost research all over the world because everyone can use it. The hardware and the software will be uploaded and completely open sourced.